good evening and welcome to the 12th Better AI Meetup. And I welcome you on behalf of Kinit, The Spot, and Innovatrics, which are the traditional partners of this meetup. And there's special thanks to Hopero, our today's partner, and the organizer of the very first AI awards in Slovakia that have been given out less than a month ago. As you may have seen in the name itself, this volume of Better AI will be special because we will be welcoming all the 5 finalists of the AI Awards. And I'm really hoping their answers to your questions will be inspiring for you in the future, and that this time, next year, more of you will be joining us here at the stage as a finalists and not just as an audience. I hope not all of you, because then we won't have audience, but other than that, I'm really looking forward to you. So before we give the floor to the very first winner of the AI Awards, please let me welcome Juraj Podrožek from Kinit. Juraj was the head of the jury that was choosing the projects that were most worthy of the very first AI Award, and he will now give you a quick overview of how the jury was deciding so that you know what you're going into next year. So Juraj, please.
Yeah, thank you. Thank you very much. Yeah, and I'm very glad to be here and then honestly talk about the things I like and I love. It's my passion to talk about trustworthy AI. So I would like to give you a very brief introduction into how I perceive, how I understand this concept, and also how we assessed trustworthy AI during the AI Awards assessment process. And first, I would like to give you a very short introduction how maybe this concept of trustworthy AI was historically perceived. Maybe we can talk about the people like Norbert Wiener, who was dealing with these questions of ethics and societal issues regarding the intelligent technologies and during the 1950s, but this one is, I think, the legend, and the man who was not only the expert in computer science, maybe you know him, it was a professor, Joseph Weizenbaum, who was one of the first men who developed, we can now say, one of the first chatbots, but he was also very keen in thinking about in this ethical some understanding and this moral reflection of these intelligent technologies. And on the one hand, he was thinking how to perceive these technologies, not from this perspective how they work from this engineering perspective, but also from this perspective if it's good to have these technologies, if it's good to develop them. And on the other hand, he was also thinking about how these technologies are forming us, how they are transforming us, and how they are helping us to better understand who we are as a people, and not only as a professionals, but also as a human beings. And when this concept of trustworthy AI was coined a couple of years ago by high-level expert group on artificial intelligence here in Europe, these experts, they were thinking about this trustworthy AI and I like this picture because it shows you how this thinking about the trustworthy AI is not only based on the legal compliance with some hard regulation, with some legal norms, and not only some adherence with some robustness standards or security standards, but also that we need to try to adhere with some ethical values, some ethical norms and principles. And this is very hard stuff to do, but we need to try. And this expert group, they will also provide us with some principles. They provide us with the 4 ethical principles and also 7 requirements. And I will not go into the detail here, but they told us that it's important to think about the things like the human agency, the role of human responsibility and accountability, or for example, how to make these systems to behave in a non-discriminatory fashion, or how to have them more transparent. And the second thing I like on this picture is that it shows us that we need to deal with these systems not only as a technological artifacts, not only as some black boxes, not only as some technologies as per se, but also we need to think about the people who are developing these systems, people who are deploying or using these systems, people who are somehow affected by these systems, and all these people are also forming these AI systems. So it is, when we are talking about the trustworthy AI, we need to talk not only about the adherence of some technical artifact to some standards, but we need to think in this broader picture of people who are somehow connected to these technologies and who are affected by them, as we saw also in this example with Joseph Weizenbaum. And that's why we decided to launch these AI awards to help Slovak organization companies to understand that is something more that only some legal compliance or some cybersecurity standards, that we need to think about these ethical norms, ethical principles, and somehow incorporate it into our systems. And during the late fall of the last year until the February of 2024, this organization who develop or deploy the systems here in Slovakia may apply for the AI awards. And together, or as a part of the Hopero project which was mentioned here, and together with the Slovak Committee on Ethics and Regulation of AI, we decided that we will assess these systems if they are aligned with these requirements, with these principles of trustworthy AI. And as a part of this expert committee, I'm very well aware that we needed to somehow cope with some really tough challenges. For example, we need to deal with the possible conflicts of interest, because Slovakia is a small country and this area of AI is even smaller. So we decided that only the judges, only the people who have no conflicts may vote for some system. And we also wanted to avoid some ethics washing, because we wanted to avoid that these companies will only pretend that they are doing something according to these principles of trustworthy AI. And therefore, we decided not to have this application the first round, but also have a second round, to have this opportunity to ask this organization personally how, for example, they are dealing with some specific aspect of trustworthy AI in their AI systems. And the third thing was about the drifting of the topic, because it's maybe sometimes very hard to understand what exactly is trustworthy AI, how to understand these requirements, and therefore we plan, and we also had several workshops and panels dealing with the question what is trustworthy AI and how to understand in this Slovak context. And also we prepared the series of blogs to explain each of these 7 requirements of trustworthy AI. And what was important for us as a committee was to know that this organization understand, for example, who are these affected people, who are these affected groups affected by these AI systems. And if the organization have some methodology or have some processes established to identify possible negative impacts. So if they are thinking not only about the benefits, but also if they are thinking about the possible negative impacts, about the possible risks and how they are dealing with such risks. And if they are aware that how these requirements, one of these 7 requirements, and each one of them is important for their organization and for their AI systems. In fact, they are all important, but we needed to know if they are able to address the problem with this requirement, to address this in the context of their own systems, in their use cases, and also provide us with some examples, some concrete examples demonstrating how these requirements will translate and how they devise some countermeasures to deal with these requirements. And in the end, it was a very great pleasure to have these great finalists, have these 5 heroes, 5 champions of AI awards, Trustworthy AI, and it was a great opportunity to announce these finalists during the Forbes Business Fest during this May. And these are these 5 companies which I think provide or proved that they are trying to reach. Maybe they are not perfect, but who is? But they are trying. They are trying to be aligned with this, not only with these legal requirements, not only with these cybersecurity requirements, but above that, the requirements of ethical and responsible AI systems. So I think if you wanted to know more about the whole process, because time is almost up, there is also a QR code, and you will find a blog about how we assess and how we understand this trustworthy AI. So I would like to congratulate these finalists and also laureate or the winner AI Dental, and wish you good luck in your journey, and also maybe for the rest of you to have these 5 finalists as an example and maybe a motivation for you to appear here at their place to be maybe the next finalist of AI Awards Trustworthy AI. Thank you.
Thank you, Rai, for the overview and introduction. And now I will have the special honor to welcome Peter Jurkacek from AI Dental. He's the CTO of the company, and he's the holder of the very first AI award in Slovakia. And he will now show you what they were working on and how they designed a solution that got award for being, among other things, very good at incorporating trustworthy AI. So, Peter, congratulations and welcome.
Thank you. Okay, I think we skipped the first slide. Yeah, okay. I think we are good to go. Okay, so welcome. Hope you will enjoy our presentation and you will know why we are trying to do our best to have trustworthy AI. So what we are doing in AI Dental, we are trying to shaping the future in dentistry, and we are specializing on artificial intelligence, and also we are trying to shape the human intelligence. And I will explain why in these next slides. Okay, sorry. Okay, so let's start with the basics. Like when we look at the dental X-ray in modern era and how they are used by dentists nowadays, you can see that I think we have the old presentation slides. That's okay, but we will go with it. You can see on the left pictures that there are like X-ray images. There are some pathologies like the decay, which is shown as a radiolucency between the tooth, and those pathologies are not visible by naked eye. So for that, we need to have the dental X-rays. So it's really important to have them also in nowadays. It's old technology, but it's very useful. And when we look at the process, like how dentist is assessing or interpret X-ray images, it looks something like this. It's composed from 4 steps. First, he needs to detect something which is suspicious in the X-ray image, for example, tooth. Then he needs to identify what is the pathological findings or something like that, like, I don't know, there is a radiolucency, so I should investigate it more. Then he needs to discriminate, like, what kind of pathology it is, like what type of pathology, and then he can make diagnose. And diagnose means, in our case, like you have a tooth decay, it's a severe, so you need this special treatment, like a root canal, and so on. So that's basic process. And when you look at it like from this perspective, it seems really simple, but then you will try to build AI on it and try to improve it, and then you find out that the performance of 2 dentists in interpreting X-rays varies. And it's really problematic when you want to train AI in that sense. And when we look at the studies which was conducted by our competitors, they found out that there are some discrepancies when dentists are interpreting X-rays. For example, on the pie chart, you can see that from the data set, which was annotated by 2 dentists, C1 and C2, 79% they agreed that there are no caries, so these are healthy teeth. But when you compare the caries exist and discrepancies, like this was the cases, caries exist, they agreed that there are caries, and discrepancies, one of them told that there is a carie, and the other one said that there is no carie at all. And this is really troublesome, because when you look at that from this perspective, it means that they agreed in 35% cases, but they disagreed in 75% cases. We conducted our own study with our data set, with our expert annotations. Our study was conducted with 4 participants, and we compared their scores. And you can see that their scores are slightly different, but the thing is that we had different tasks. Like, we just give them X-rays, and we wanted from them, like, annotate the region of interest, which was tooth, and tell us if there is a decay or not. And it's like really simple task to classify for regular human. But as you can see, they also have some discrepancies. They agree that there are 18% of the caries, and they disagree that there is 18% of discrepancies. So they disagreed, basically. And when you compare those 2 agreements, you can see that it's 50-50, which is still not very pleasant from the patient perspective, because when dentist is telling you something, can you believe your dentist? Like, it's a tricky question. So what we are trying to do and how we are trying to deal with it, there is another challenge in those areas, and that's tooth decay is just not enough. When you are building AI system for the dentistry, like, the decay is only one part of a pathology, and you need much more pathologies to cover when you want to build something which is robust and which is complex and which can give you like a whole report, basically, as regular dentist is doing. And just for example, we already know that there is more than 30 pathologies, different treatment recommendations, and also dentist has to assign like 60 different attributes for all of those to be able to diagnose your problem correctly. Yeah, so I just pointed out a few challenges which we have there. So I just want to sum it up. Basically, we have to deal with subjectivity, radiograph complexity, and operational challenges. And all these factors influence the precision of regular dentist when he is interpreting X-rays. And what we are trying to do, we are trying to focus on all of them if we are building AI, and we have to be aware of them. And that's like, let's fight them together. And what we are doing, basically, we are trying to connect human intelligence with artificial intelligence. So we build a platform which is for education purposes. There are multiple activities which you can use as a student or as a dentist, and you can improve your skill in interpreting X-rays. What is interesting, like, it's publicly available, so anybody can do that, and we are trying to improve the overall education in the interpretation. But in the back end, in the background, we are using it as a crowdsourcing platform. So we are sourcing data and annotation from different professionals to be able to train better AI, which is objective and not subjective. And when I'm talking about the subjectivity, like, there is one thing. We are trying to embrace the unsureness which is in the data, especially when you are interpreting X-rays, because you see that there is a tooth and you don't know what is there. But based on our experts, they said that, yeah, there is a decay, but you don't know where. But we know that 4 of them agree that there is a decay, so we know that there is a decay. And what is interesting on this certainty aspect, that we are not just getting the binary label, like there is a decay or not, but we are getting some kind of score, like I'm sure on 80% that there is a decay, or I'm not as much sure, like 20% that there is a decay. And basically this is creating something which is called soft labels. So if you are from the AI, maybe you are familiar with hard labels. So basically when you are training binary classifier, which has, for example, ground truth 0 or 1, these are hard labels, but soft labels are more about the probability of the positive class. So this is really interesting aspect which you can use to train these kind of AIs. And we saw that it stabilized the training, so we get better result with the soft labels than with the hard labels. Okay, another aspect which we are trying to deal with is the radiograph complexity from the point of view, like you need also radiological view and also clinical view. And these are different, and I just wanted to show with the matrix how we are visualizing like the data set which we are gathering. You cannot see it, it's intentional, so sorry about that. But in the x-axis, you can see that there are 2 numbers. So basically, we have each separate tooth, and for each tooth, we have different findings. And thanks to those heat maps, we can see like what is the prevalence of specific pathology for specific tooth. And we can also assess like how our data looks like. And we can spot if there can be some kind of bias in specific tooth number or something like that. So it's a really cool way how you can visualize it. And just for fun, we was able to collect till now more than 200,000 opinions from the clinical view perspective, and more than 700,000 opinions from the radiological view perspective through our application. So the Edu application which I mentioned. Another thing, like how you can deal with the radiograph complexity. As you can see, we built the catalog of cases which have different pathologies, a lot of them, as I mentioned. It's really necessity to have them. And the thing is that when you have those data sets, you need explicit consent from the patient. You cannot just download them and public them, because all radiographs from the dentistry, they are personal data. So you cannot use them without the explicit consent of a patient, because patient is the owner of the data. And all the data which we are using, we collected with those. We are showing them to users, so user can see like which data we have and which data we are using to train AI. So it also boosting the transparency of our AI. And what is interesting, like we generated different cases for students and for dentists to annotate with object detector. So we train object detector on small data set, and we use the annotation to automatically annotate them, because the object detection in case of tooth is really simple task. So we didn't have any problems with that. And also there is an aspect like when you look at the tooth, you don't know what is there. But based on our expert opinions, you can see that there is a decay, because 4 of them said so. And like if you want to explain why, it costs time, also experts, and it's really precious, and we don't have their times most of the time. And for that, we are generating heat maps thanks to the AI. We are utilizing the GradCam currently, which is basically, we train the classifier which is classifying the case, and then we use GradCam to show which pixels are the most relevant for this positive class. And that's what we are showing to the students. Also, we are showing them like our AI is certain in 78%, Also, you can see, okay, you cannot see there, but yeah, our 4 experts said that probably there is a decay. Probably means that probably 70%. But thanks to this mechanism, also if you are a clinician and you are looking at the radiograph and you can see the expert opinions and also our AI opinions, you can see like if there is something wrong or is it okay and how it performs. Yeah, and when we look at the backend, basically, we built simple pipeline, which is really simple because it's composed of some classification model and detection models. And there is a GradCam, which I mentioned, but it's not on the pipeline. But basically what we are doing, we take radiograph. There are different kinds of radiographs. So as a first step, we need to classify like what type of radiograph it is. For example, OPG or bite-wing. Then we detect region of interest, for example, tooth, and then we classify those. And what we have there, like there are multiple classifications, classification models, which we can use to classify which pathology is there. And they are really like a simple binary one, so it's not that big deal. But we can compose them, we can extend them as we want. Also, we can configure them. So it's really good to have this kind of modular architecture, but it's hard to maintain. But you can also do it if you have right tools. For example, we are using MLflow. We are tracking each experiments. We are evaluating the scores and so on. So it's easy for us to maintain them. And like when you ask like if our AI is trustworthy, that's the question. And I would say that it's not trustworthy based on this radial chart, which you can see. Otherwise, we would have like 5 score in each row. The radial chart, which you can see, it's from the Altai. I don't have link there, but yeah. You can do it also in your company, and you can see how good your AI is in terms of trustworthiness. It will give you score, and thanks to that, you can focus on areas which you need to improve. Just to mention, as you can see, we have the biggest score in transparency because we are showing the data set which we have. We are also showing the AI which we have. We are also good at privacy and data governance because we are trying to use data only with the explicit consent, and we also trying to be aligned with the GDPR. So if each of our patient, if he decide to withdraw the consent, we can remove his data. And also we are good at the social and environmental well-being because we don't need to require real-time inference. As you could see, the GradCam and the heat maps, we can just run it, and we can bring the value of AI to students, and they can get something from it. So that's like the main point. And as you can see, there are important things which we need to improve, like the diversity, non-discrimination, technical robustness, and safety. And that's because yeah, in the questionnaire, there was some questions which we answered, and we got this score. But overall, it's really hard to do the technical robustness and safety, especially when you are focusing on wide area of different pathologies. So because we have to accurately annotate or accurately say how good we are in all of those pathologies to be able to tell like what is our accuracy. So that's all from my side, and that's it. So if you have any question, feel free to ask.
Thank you, Peter, and thank you, everyone. If you have any questions, we will be getting to them during our Q&A session. I have to say that when I saw your presentation for the first time, it got me really excited because it was full of interesting information. And this is really special because I don't think anybody is excited about dentistry at all. So thanks for bringing this here. Now I'll ask you for like a minute of patience because we will need to arrange our discussion, but right after that we will get to the questions and answers. So thank you and stay with us. Welcome back, and let me welcome all the finalists of the very first AI Awards. Let's just say that we at Better AI Meetup are indeed better because most of them have been already here. So I'm very glad that you know that we have a good taste for our guests. And you already know Peter. Let me welcome Martin Brezina from Gerulata Technologies. He's been with us, or Gerulata has been with us in the past, Better AI Meetup. My colleague Igor Janos, he's the synthetic data lead in our R&D team. Tomas Koctur at the very end, he's the head of AI at TrollWall, one of the few that hasn't been here, and sorry for not inviting you sooner. And TrollWall is basically using AI to secure online space against hate speech and provide discussion moderation with AI. And Boris Vavrik, he's the head of AI at Powerful Medical, and you could have met him some 4 months ago in our Better AI Meetup. So guys, welcome and congratulations. Thank you. And I will just first start with the questions from our side, and we will welcome your questions at Slido hashtag better_AI. So feel free to add any of your questions during the time that we will be here. And I will just start, let's say, from a question that pertains to all of you. What are like the important characteristics of trustworthy AI for you and your product? I mean, Peter, you've already mentioned it, but for example, Martin, I mean, at Gerulata, you're working with lots of data and basically security, so trustworthy is very important to you.
Sure, of course. Briefly, a couple of words about what we do, and it will make sense what I'll be saying. So what we do is we harvest a lot of open source intelligence data. We save them in our database, and then we give our clients an option to sort of search and find these little nuggets of insight in vast amounts of data. And to do that, we are using and employing different machine learning models. Right, and so what the question was, what does trustworthiness mean for us?
Yeah.
So there are a couple of different aspects to this. So firstly, we have our ethical standards that we are trying to align with. It has to be transparent, so our clients, and there is also a feedback loop, so our clients can see what the output is, and if they find it wrong, they can always change it. And also in our platform, if there is an artificial intelligence output, it's always clearly labeled so that clients know that they are working with AI data.
Mm-hmm. Okay, Igor, I mean, you're working with biometric data, so what's the important part there when we are talking about trustworthy AI? What's biometric is quite controversial and everything, so.
Thanks for asking. Yes, biometrics is by definition critical. So all of our data is very sensitive, and we really have to do good data governance. And we try to use a lot of synthetic data lately because, of course, you don't need to protect it that much. So basically, we measure all the aspects and try to model the properties of, I'm getting too much echo. Yes, okay. So we are trying to model the properties of the data that we are working with, and we are trying to find new creative ways how to improve our data. And also, it is very important for our products and our algorithms to be accurate, precise, so we have to really think about any kinds of ways that our algorithms can fail. So yeah. I guess that's that.
Okay. Boris, I mean, you're working with electrocardiographs and with a very special, let's say, audience. So, what's the most important in trustworthy AI for you?
Our mission is simple. We need to, or we would like to, improve the patient management and avoid some diseases that are not necessary to happen. And with this in mind, and with the highest interest to help the patients, the highest importance is within the diversity of the patients. The patients varies a lot from the geographical perspective, ethnicity, age, and either some combinations of different diagnoses that could result in a very, let's say, different results than expected. And all of this has to be taken in account. So our biggest focus is to collect the most wide spread of data across the world, as the product is a worldwide product, and to be really confident that the AI brings the value to all of the patients, regardless their metadata, I would call it just.
Okay. Yes, and Tomas, I mean, you're working with hate speech and basically online space. So how to keep the AI trustworthy so that it's reliable, so that I know it's filtering the right content and let's say, wrong content and letting in only the right.
Definitely. So it's hard. It's hard for our annotators to read those stuff, actually. So it's a lot of vulgarism and hate speech there. So it's hard mentally as well. But how we achieve our trustworthy AI? It's basically to emphasize the word trust. So how you can trust the AI model. So for us, it's to build it from the scratch and our own model. And also build our own data set to train it. So that's why we have full control of what we expect from our models to moderate on the social media and monitor and test. Constantly test automatically and then manually by the QA specialist. So, and then we can ensure that our model is working how we want. Yes, and also test it against the biases, and that's it. So I think
Yeah, I think that's the common theme among all of you, because I mean, all of you are working in AI, so you usually test automatically and manually and augment your data sets. So let's move to another question. How do you actually deal with the need for explainability and understandability of your AI output? And I will just first, I think, start with the medical part of the of you, and let's start with Peter, so that you are not silent for too long. I mean, your AI gives output to basically like non-technical stuff similar to powerful medical. So how do you actually deal with this, with the need for explainability to understand how the system got to the output it got?
Yeah, as I mentioned in my presentation, like we are trying to show the world what is our AI and how it's working. So, and also we are trying to show them, for example, you could see the heat maps. And like when you compare those heat maps to other dentists, like what they think, sometimes those heat maps are wrong, and you should be aware of that, because sometimes just the heat map is not in the center of the pathology, but sometimes it's just around the corners. So it can happen, and you as a dentist or as a student, if you are using our application, you can see that. So we are trying to teach you how to use the AI. We are trying to also mitigate the over-reliance, because we are trying to foster the critical thinking of our users. So yeah, and we are if we are talking about the explainability, there are different levels. Like for example, there is a level on pixel level, which can be represented by a heat map or polygon or something like that. But you can also use large language models for that, just to textually explain like what is going on based on some features which you can extract from the image and so on. So that's what we are trying to achieve with the explainability, and that's my answer.
Yeah, okay. Boris, I mean, you're dealing with cardiologists, again, like non-technical stuff that, you know, care about heart, which is, I heard, is quite important for you. So, how to actually achieve the explainability, understandability of the AI output?
The first step is by the design of the solution. We are trying to connect together not only the neural networks, but also some algorithms, and in so many steps that is possible to see at which stage the expected result diverges from the expected results. And the way how we do it is that we have lots of components that are individually evaluated and somehow monitored, and we can see where the mistake happened, and we can address it much better. That is the first step that we have taken. And the other one is, it's a bit of an experimental feature, let's call it, because we have kind of like a heat maps that was shown on the presentation of AI Dental, but these are hard to regulate. As we are in the regulated field, anything that is not like measurable or exact, you can't really define the behavior and what it has to do and how it has to behave. And we just like provide it to some users that are very well aware of the feature being experimental, and they are happy about the results, but we still need to find a correct way how to regulate it and make it a normal basic feature that is reliable for the people to use. And that is the biggest challenge that we need to figure out, because just showing something, that's the easy part. But being really like tier 3 level confident about the correctness and about the information, what you see and what does it can mean, that is the tricky part of it.
Okay, I will ask Martin, because I mean you already mentioned the importance of explainability. I mean showing the user why it gives you the results it gives. So how do you approach like explainability and understandability?
I'm sorry, thank you. I'll start with saying explainability is very difficult with machine learning models. But that being said, we have two approaches. So first is to explain. Whenever we, for all of our clients, we have a multi-hour long training session where we go through all the features, and then we stop at every AI model and try to explain what insights they can gain from there, and what are the potential limitations, such as we have a sentiment analysis. It's not a entity-based sentiment analysis, but just it looks at the entire length of text and sort of tries to assess what is the sentiment. And there are obvious limitations to that. So we try to sort of explain to our clients these things as well. The second thing is to make it as intuitive as possible. So whenever we are using soft labels, we try to show the probability of, in terms of classifiers, the probability of that class being applicable to that particular use case.
Mm-hmm. Thank you. And I would also like to ask the same, Tomas, because I think explainability, if it's not already important, it will be like in very near future for social media and so on, because people usually object to when they are blocked on social media.
Yeah,
so
definitely. So. So TrollWall is not just a language model or classifier connected to the social media, but it's also the whole content moderation platform. So our users are able to log in and actually moderate the content. They see clearly what was hidden from the Facebook, not delete, but hidden. And they can still override the results. And from our technical part, as was said, with deep learning models and language models, it's hard to explain the results. You still can actually work with the attentions of the model and see what was the biggest contribution, which tokens or words were contributing to the output most. But this is not a simple task, because these models doesn't work with the words or tokens, but they take the context as a whole. So this is good for explaining for our research team to actually work with the training data to find the discrepancies and stuff like that. Yeah, but our users definitely can see what was hidden and why, and can override it.
Okay, thank you. And Igor, I mean, our clients also usually want to know why, for example, my face is rejected, when it's clearly my face and so on. So how do we actually approach, trustworthy, the understandability, explainability of the results for liveness, for example?
Well, as far as identities are concerned, the bad thing that can happen is that somebody else might pass as you. And we usually want to avoid this. And there are two strategies how we can do this. Either by training like really, really good model that can solve everything. And the other way is avoid the problematic situations. So we can identify when does this happen, when does our model fail. And maybe it's like bad lighting, maybe it's too much contrast or stuff like that. And we can train different models which identify the situations and then navigate the user. Move your head to the left, move your head to the right, adjust the lighting. So you will not really get into the situation that is difficult for the model to compare.
Okay. This is nice. Are you afraid of your customers being over-reliant or negligent toward the output of your system? And how do you deal with it? I think this is basically the best question maybe for Boris and Peter, because you're dealing with human health, and I can imagine like both cases that either my doctor ignores the output of AI system altogether and just goes with it, and you just showed us how incongruous the decisions of the professionals could be, or he's just over-reliant and is just believing everything that spouts out. So maybe I'll start with Peter. So how do you deal with this?
It's connected to the explainability, basically, because overall, if someone is overlying on your model, he don't know if it's working or not. And in our case, what we are trying to do, for example, the soft labeling, because we are trying to give the certainty in a level in which it is. So basically, we want to show them, this is not very certain prediction, so you should not believe in that. And we are trying to foster that also with the education platform. So it's really connected to things which I've already said with the explainability.
Yeah. And also with the soft labels and everything.
Yeah.
Okay, and Boris, how do you actually deal with, cardiologists like being over-reliant on your systems, for example?
To answer the question, if we are afraid, I would frame it in a perspective that we are not afraid that we would not know about it. As we have a solid post-market surveillance, we are really tracking the behavior of the people and the users, and we track all of the weird behaviors or some outliers in the aspect of how they use the application. And by this tracking or monitoring, you can see some problems to look for and to address them. And for some short-term period, we had already successful prospective studies done with people using the application right away during the patient management. And the results are above expectations, so better than we have already predicted from our evaluation before. And the long term is hard to guess how it will evolve, but I'm sure that we'll know whether this is happening.
Okay, this is nice. So it's a good thing to actually do, like the let's say post-market survey, post use. Yeah, okay. This is maybe a question for mostly Gerulata and TrollWall, because you are using the natural language processing based inputs and outputs. Are Slovak language models like similarly robust to English? That would be first part of the question. And are there differences in outcomes, like meaningful differences in outcomes that are like language dependent? So for example, something that happens in English but doesn't happen in Slovak. Maybe I'll start with Tomas.
Thank you. That's actually a very good question. So it depends on the use case what you are using. So if we're talking about the large language models, which we don't use for classification of hate, so then if you're using Gemini or ChatGPT, maybe you see there is a difference in Slovak and English language. I think you see better results in English, and we know why this happens, because there are like two major steps in training large language models. Which one is the self-supervised pre-training with the vast amount of the data, and the other one is the supervised fine-tuning. But this pre-training is done on the publicly available data, and the Slovak language has only contribution 0.36%. Czech language has 1.12 or something like that. So it's only small amount of the Slovak data compared to the other languages. English is like 45%. So we see there's distribution is not even. So we cannot expect it will be very robust. But if I can extend my question, my answer a little bit, if you just take all the content available in Slovak language on the internet, would you be able to say that, okay, this is a good representation of Slovak language? If yes, then these large language models can work in Slovak language. But there's the second part, the supervised fine-tuning, when they have these instruction data sets like, how can I do this in Python, and I want to convert it to, I don't know, Java, whatever. And those are usually not, so there is very small distribution of the Slovak data in there. We don't know, because it's not disclosed by the Google or either OpenAI. So we don't know how much data is there in Slovak language. That's why we see lower performance, but for the LLMs. But we are not using decoder models. We're using encoder transformer models, multilingual, and we see they can work very well in Slovak language and in the other languages, because we anyway fine-tuning them with the different data sets in the Slovak, Czech, Polish, and German. We have like multiple markets which you are covered now. So we see that if you have good supervised fine-tuning data, then you can have a good performance even in the Slovak language with use of multilingual models.
Thank you. Martin, is it similar in Gerulata as well? Or are you working with Slovak data?
To some extent, but our need is not necessarily only or focused on Slovak. We are focusing on sort of a multilingual approaches to working with the textual data. But that being said, I think the second part of the question was, are
there meaningful differences? Yes.
Yeah, so there are meaningful differences, but I also think specified models for Slovakia, such as the Slovak bird model, which was trained by Kinit, amongst others, for Slovak language is better than any other multilingual sort of model, if that makes sense.
Yeah. Now, a question for everyone. How does training your models actually look like? Where do you get the data? How do you make sure the data set is robust enough, not too biased? I mean, we pretty much covered it, right, Peter? But if you have something to add, just you can start now.
Okay. I think I didn't mention the variety of our datasets because we are trying to have a contract with different clinics around the world. So we are trying to also cover the different biases regarding the demographics of the patients. So we are also collecting those from the gender perspective, age, and also ethnicity. And also that's the reason why we are trying to build we've built the Edu application, because thanks to that, we are able to reach universities around the world. So thanks to that, we can also collect more diverse data, and that's how we are dealing with it. So.
Yeah. Martin, how do you train your data sets, or how does training your models look like?
I like to joke that when you have a big machine learning hammer, everything looks like a nail. So my colleagues are using and training classifiers for things that might not necessitate a classifier or machine learning model. But how does this work in practice? We are using, depends. We have so many different machine learning use cases, but for most of it, we are using a combination of real-world data, either by some gold standard, either from some gold standard data sets, some of the data from our own harvesting and from our own sort of real-world usage, and then synthetic data. We also generate synthetic data.
Okay, thank you. Igor, how do we actually train our data sets?
Well, that depends. Depends. We do quite a lot of different tasks in our company, and we have a great many data sets. Some are really large, millions of images, so you go periodically and clean, and train all around the year. But on a few occasions, we have already trained on purely synthetic data, and these are really I love these cases, of course, but we also collect our own data sets as well. So.
Oh, yeah. You may remember Igor talking about fragmented fingerprints that we needed for criminal use case, because simply police doesn't share with you like fragmented fingerprints from criminal sites. So that was quite fun, I have to say. Boris, how do you create your data set and train your models?
I would like to say that there is nothing like a robust data set. It's like a myth that you just want to achieve, but you will never get it. Especially in medicine, we try to get the data also from the geographical zones that are not that very well digitized or digitalized by this time. And that's why we even developed the digitization part of the product that we have, that we can extract the ECG signal from the paper version that is still much more common than I would like to in many states. And this provides us like a new gate to the data that were totally lost somewhere, and we can revive them from the ashes and bring them to our evaluations. Still, it's retrospective, but it's better than nothing. And that's how we approach and how we gather the data also from the challenging geographical regions.
Thank you. And Tomas, how about you? How do you actually approach the training? Because I'm assuming that the online world is constantly evolving, so we have to react.
Yes, exactly. So as I said, our TrollWall is a social media moderation platform. So there is multiple models, but the main one is the hate speech detector. So how we actually approach that? So if you Google a hate speech dataset, you find like 100 references to the different datasets, which like every single one is different quality, different measures, different level of hate speech is allowed. So actually they are kind of useless. So we created our own datasets from the social media comments, which we annotated manually because we are in the different regions. So with the native speakers, which are linguistic experts, and we annotated every single comment with the 3 different independent annotators, and then we find the discrepancies. So that's important also to don't bias the models. And then we actually train them. Then we actually doing the final check with the other data sets. As I said, also we if we don't cover some topic very well, we creating data manually, and we also using a Gen AI to generate the data, and then again we annotate them manually. So a lot of manual work, and actually a lot of stress to the people which annotating, because reading those comments, it's like painful.
Oh yeah, I fully understand. It has to be sometimes crazy. So before we get to your questions, I have one more question to ask, most of you at least. Your products can often be used for ill or bad purposes as well as the good ones. So how do you actually deal with the bad cases? Do you have some sort of framework around it? Let's start with, although I'm not sure if this is a question really for you, because but maybe you have been thinking about it.
Actually, we were, but yeah, we didn't think that it's our field to cover right now. So probably that's for my colleague's question.
Yeah, definitely. In Gerulata, I think this is a much more, let's say, important one. Who are your clients and who you are talking to, because the information can be used for different purposes. So how do you approach like this, let's say, ethical question of using your system for ill purposes?
So I don't think we have any experience with, bad experience with the usage of AI. This is the first thing. The second thing would be that we choose who we work with. So we would never work with, so who we typically work with are pro-European institutions, democratic governments, researchers from established Western universities, and so on. We would never work with any malign actors, if that's
okay. Igor, what's your opinion on on biometrics used for ill purposes?
Yeah, I guess this is covered by the European Union AI Act, because biometrics can really be used in many hurtful or harmful ways. But there's not really many opportunities, I would say, to integrate some kind of protection in the matching algorithm directly. So I would agree with my colleague. You have to be careful who you work with. And
yes, Boris?
It's pretty hard to imagine how the AI for better diagnosis of ECGs could be somehow harmfully used. The only potential harm that is here is to intentionally somehow change the data to hide or make the AI not predict the diagnosis that should be predicted. But this is more to the security part of the solution. And I'm not very expert in it, but we had definitely some attacks already, and all of them were with no effect for the patients, for the users. So we are successfully securing our AIs in the clouds.
Okay, great. And Tomas, how about you? I can fully imagine that the TrollWall could be used, for example, as a censorship platform as well.
Well, to be honest, so we are as a platform
we don't offer services which are not usually done by the humans. Social media moderators usually moderate their discussions. They can go to the censorship level. So there is still chance that, okay, we providing more efficient solutions, so they maybe could use that. But what we actually see is a funny thing that somebody, let's say we have some company, and some supporter in the comments can be vulgar against the competitor. And this can be also hidden, usually are. These kind of comments are also hidden. So, it depends on the social media managers. They usually do it. They were used to do it. Now, if they are over-reliant to our system, then it's actually we mitigating this process because they don't look into the data anymore, and maybe they don't doing it that much.
Okay, thank you. Thank you for your answers for my questions, and we still have questions from the audience. So I will go by like the most important ones. So if you see a question that you like, just put there a like, and it will jump higher. But we will try to answer all of them. So it was mentioned that the environment well-being is a part of trustworthy AI. Are you aware of the environmental impacts of your models or in trainings and so on? Or did you try to measure them? And maybe let's just move. Yeah, let's start with the with the usual order.
Oh, okay. Yeah, like for us, the environmental well-being is also an important part of the AI, and yeah, we are trying to, for example, when you don't need to do real-time inference and you can do it once. It's much better than, for example, someone is uploading same X-rays and so on. And like we didn't measure our impact in environment, but yeah, we think that the way how the AI serves to the users, that's important. It needs to be think through. And in our case, right now we are good to go with the offline inference basically. So that's how we are dealing with it.
Yeah, so lowering the the real-time load. Yeah.
Yeah, we are trying to bring the value of AI, and if you can do it not real time, that's really important part.
Yeah. Martin, how about you?
I don't think we have measured the environmental impact, but I also don't think they're very I mean, our AI models are very harmful to the environment. There is the question of compute, but we have a couple of A100s, and I don't think they, in the grand scheme of things, I don't think they are the biggest problem for the environment.
Yeah, Igor, how about the Innovatrics? I know that you love our big graphical cards for for everything.
Yeah. Well, we don't have them that many.
Okay.
So I would say that the training part is not really that great impact. And as far as inference is concerned, we are greatly investing into development of embedded devices, training of small models, distillation of small models. So we really like our models to be as small and as efficient as possible.
Yes, Boris, how about you?
Similar as was said previously, I would split to development and the deployment part of the solution. And deployment runs on the smallest possible hardware that is capable of running the system, and it is scaling by the number of requests automatically, and not being just run all the time, all of the instances. And for development, we use so-called spot instances in AWS, which means that those are the instances that are not used currently for anything, and AWS provides them for a lower price, and also without the guarantee when the code will be actually executed. But that's totally okay with us because the research is not that quick, or we don't need the answers immediately. So we are willing to wait a bit for AWS to allocate their instances and provide us the results when it will be the cheapest and easiest solutions for them. And that saves a lot of electricity and mitigates the environmental negative impact.
Tomas, do you measure that as well, or?
Yeah, definitely. So we see the trends from the lot of startups these days in NLP that they're using LLMs for everything, and this is, I think, the very wrong attitude, because if we compare our classifiers, it's based on the encoder transformer model, which has several hundred millions of parameters, and if we say ChatGPT 3 and for free has like 175 billions, and OpenAI didn't disclose the ChatGPT 4, but it's expected to be on 1 trillion parameters. So it's actually a lot of compute to do even in the inference time. So it's natural not to use such a huge models if you don't necessarily need them. So, and also it's much lower the cost of running them. And also means that if you need that much compute, it also electricity, CO2. So yeah, it's natural even from the business perspective and from environmental perspective to have models as small as possible, and that's what we do.
That's actually very nice that you know that the economics and environmentalism are like across in this case. So I will continue with the next question. Did you find some unexpected stakeholders that may be vulnerable to possible ethical risks besides the usual suspects as end users, clients? So usually like other people that could be affected by your models and not those that like directly use them. Yep.
I think, okay, yes. So for us, there are a couple, but they both sort of come from the GDPR compliance. So for one, we never harvest, or if we do, we anonymize the data of public users. But for example, on Facebook, we don't harvest data of public, even of private profiles, even those that are public, if that makes sense. The second would be the second example would be face recognition. Even though we have some demand from our clients to do face recognitions on images, we don't do that because of the GDPR compliance.
Okay. Yeah, that's nice. Any other answers? Okay. This is a nice question for Gerulata and TrollWall, which crossed my mind when Tomas mentioned it several times. How do you actually deal with the impacts on well-being of annotators that need to face like the huge amount of harmful content? Maybe start with Tomas.
Yeah, as I said, it's very harmful to read them sometimes. But actually, this dirty laundry must be washed. So they need to do that, but we actually don't. Well, they work remotely and they have like very vague deadlines. And they can work whenever they want, so they're like not forced to be 8 to 16 in the office. So I think this is the only way how we can deal with that. I don't see any other way.
So you give them space to actually relax. Yeah, and how about Gerulata?
We don't annotate that much data, but that being said, we are working with social media data, and if you've ever been on Facebook, you've seen all the things that are there. So, I mean, I guess everyone in our company needs some time to sort of, what's the word I'm looking for? To decompress from the day's work.
Yeah, I see. Okay, we have a question specifically for you, Peter, for dental AI. Do you also use any more objective labels in your evaluation process instead of just dentist annotations?
Yes, we do. As I mentioned, we are also collecting the clinical perspective or clinical data. And in those data, you can imagine that it's some kind of structure, digital fingerprint of your visit, basically. And in that visit, you can see like all the pathologies which were diagnosed by the doctor. We are still in a subjective annotations, but we also have flags like which procedures were done in this specific visit. So thanks to that, we know that, okay, this was real deal. So we still have the objective ones. And also we are doing cooperation on research. In which we've agreed that the dentist will send us exact picture of a tooth after drill, and basically you can tell that there is really a decay, for example. So
okay, yeah. So you're checking the correct. Okay. For Gerulata, isn't multi-hour training session for your customers like introducing a bias in interpretation of your product?
Right. I don't think I understand the question, but because to me it seems that it introduces clarity rather than bias into interpretation of our product. But our product is fairly complex, and there are not only AI models that need to be explained, but there are different approaches, and every couple months we have a new release with new features. So it's like a Swiss knife for analyzing open source intelligence and open source data. So if I did not answer the question, or if I didn't
I think it was maybe like interpreted in a way that you do like a special maybe training for specifically for the data that your customer is interested in or something like that, but not really sure. So sorry for that. Yeah. So if it was someone from here, you can just ask Martin like when we finish for more specifics, and I believe he will be happy to answer. And we still have one more question for AI Dental. When creating the heat maps with your AI, are there some pathologies or cases that are easier to diagnose than others?
Yeah, definitely. For example, the filling, you can see that there is a white spot in the picture. So there are some, but it also depends like not only on the finding, like it's a variety, because, for example, you can have decay, which is really easy to spot, but you can also have the disagreement ones. So yeah, definitely there are some cases like that which are easy to spot, and also for that we have like the great accuracy, but for the harder ones it's harder to get better accuracy. So
of course. Yeah, and there's still one more question for you, and that's a score from your Altai radial graph that scored 2.33 out of 5 is basically a failing grade. So is this something acceptable for your solution?
Yeah, it is, because I mentioned we have two solutions. One is still not certified, so we are still not putting the AI into clinic to predict the diagnosis, because we don't have the robustness which is necessary to have, and we are aware of that. So I think it's a good thing for us, because we know that we can harm a patient. So yeah, I think it's still good if it reflects and if it shows you like what you need to improve. So in that case.
Thank you. And there's still a question for you, and I will probably put it to Igor as well. When person removes their data through GDPR process, which you just mentioned, how does that affect your models, and do you need to retrain them like without the data?
Yeah, that's a thing, like more about the data management, which we have. We are doing dataset releases, basically. So we use each release to train a new models, and we can like remove the release. We can retrain the model on new release, so it's not that problematic. Also, we have the specific identifier which we can internally use to somehow manage to know like what are the records, but we don't know the identity. All the data, personal data regarding name or ID of the patient and so on, we don't have. It stays in the clinic, but in the clinic they also have the ID which they can use to remove the patient data from our databases. So it's not really hard to do for us to remove those data.
Okay, thank you. Igor, how do we approach this? Because, in biometrics, this is like a very touchy question, about having your face in a data set.
Well, we try to have our data anonymized, so there is no clear connection between a person's identity and their image or maybe fingerprints. But if you really need to remove some data from our data set, then there is, of course, the life cycle of the entire model training, and it's not instantaneous. So, like, remove the picture and everyone has the new model. No, it takes time. So.
Yeah. On the other hand, if you want to have your picture removed, you can just, you can just take your photo and our facial recognition will find you immediately in the data set. So that's easy. That's the easy part. So, we have a nice final question here for, I guess, most of you. How do you see the future of development of AI classifiers in the age of generative AI? Will there be more synthetic data sets? I mean, most of you, I guess maybe even all mentioned, you do at least some synthetic data sets. So how do you see the future of development of these AI classifiers? Maybe start with Peter.
Yeah, we think it's a future, but you need to have a robust base to be able to generate synthetic data, especially in the medical field, because you can present some artifacts into our data if you are synthetically generated them. But yeah, we see it as a way how we would like to go. But for that, we need to have a robust base of number of the data sets which we have.
Martin, you mentioned that you also produce your own synthetic data.
Yes, so for us, we are working with textual data mostly, so it's very easy to create synthetic data sets to train our AI classifiers. And another thing that I sort of expect to see is to see fewer AI classifiers, because now it's extremely easy to create an API wrapper around OpenAI API and call yourself an cutting-edge AI company. So there won't be as much need to train AI classifiers, I don't think.
Yeah. I mean, Igor, you're a synthetic data lead, so what's your opinion?
This is actually a tricky question, because on one hand, we want to have really good synthetic data, because we want to train our models, and we argue that we don't need to protect the privacy of the people involved. On the other hand, we have a liveness detection where we want to detect deepfakes. So these are competing interests, but my opinion is in the future, the generative AI will get better, and the way how you can detect if an image or some data point is synthetic or not, it's not going to be possible. But at the same time, it is still going to be very, very expensive to train a good generative model. So depends on how much are you willing to pay.
Okay, thank you, Boris. You mentioned at least some synthetic data in your work. So how do you see the future of
The synthetic data are already here, and nobody worries about it. We have lots of augmentations, data generations, and that is normal development process that you want to do a lot of synthetic data to be robust for the edge cases. I'm not somehow afraid of the development process of it. It just needs to be held in the development phase and not anyhow leaked to the evaluation phase or the validation phase. And then it's totally okay. It doesn't really matter on what data you have trained the model if it is correctly validated later on real data that are within the intended use and the intended population.
Okay. Thank you. And Tomas, I mean, this is a question I think that you're looking into as well, because sometimes I have a feeling that in social media it's like bots fighting against bots, usually in the comment sections.
Yeah, definitely. So we had the problems with this when we started, because you can ask ChatGPT to generate you some hateful comment, and it does not allow you to do that. So luckily there are open source models which we can utilize, but mostly this is only just to fill in the gaps in the data sets, because usually if you go on the comment section, you can see that we as Slovaks can be very, 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 very creative in creating hate speech and vulgarisms and using different kind of covering it to don't be detected and hidden. So we need to annotate a lot our own data. So yeah, and we still fighting and trying to get more synthetically generated data for the different aspects, not just hate speech, because we are not detecting just hate speech, but also the other aspects. And this is actually allowed by the providers, LLM providers. So yeah.
Okay, so it's very nice to hear that at least in generating vulgarisms we are much better than generative AI. So this is reassuring for future. There is still tricky question for dental AI, but I think it goes for all of us, and I will try to answer in Kinit's stead, because the question is that if your partnership with Kinit before the competition affected the results of the AI awards. I think everybody here has some partnership, and even in the non-finalist part, and I think Juraj mentioned it, so I just reiterate, every time there was a conflict of interest, because Kinit was not the only one in the jury, but basically the jurors that were in conflict of interest were just not voting for the specific. And the other jurors were, for example, from the Ministry of, I think it was Ministry of Informatics, from that was the constant commission for AI, for AI, something like that. We actually have that. So. And these guys were not in any way involved usually with the companies. So Juraj mentioned it already, so I just reiterate that every time there was a conflict of interest, then the jurors just did not vote, so it would not affect the competition. So, yeah.
Actually, I'm the member of the committee for regulation and ethics of AI. So,
yeah.
So if we would be so much biased, so we would won, but we didn't.
Yeah.
So
Yeah, so as you see, I mean, yeah, the AI community, as you can see among ourselves, is really small and really closely knit in Slovakia. I think everybody's connected through Maria Bielikova, who is usually here. So you know, this is really difficult, but they really try to project it in a way so that it would not, it would be really independent. And with this, I thank you for all your questions and for your time and for staying with us. We will see each other at the 13th Better AI Meetup in October. And before that, you know, just think about what can you do with the answers that you got from our guys, which I congratulate once again for your products. Yeah, great work. And, you know, just think about what you can do with what you heard, how to actually get to these high chairs next year. Thank you and goodbye.